Hello everyone, I am Konstantin Echavez, a first-year chemical engineering student from Xavier University, Ateneo de Cagayan. Ever wondered how materials like nylon and polyester are made? How is it possible to make food stay fresh for longer? Or what happens inside a water treatment plant? Maybe you know all that, but are curious about how bionic plants, fog harvesting, and carbon nanotubes can be used to improve the world around you. These are just some examples of topics you might cover as part of a chemical engineering degree. Essentially, the study of how to turn raw materials into useful, everyday or perhaps more specialized products. Chemical engineering, on the other hand, is described as an engineering subject that entails the design of processes that transport, alter, and generate materials. To develop these processes, chemical engineering students and chemical engineers must have a thorough understanding of physics, chemistry, and mathematics. But before anything else, let's talk about the Bachelor of Science in Chemical Engineering here in the Philippines. The Bachelor of Science in Chemical Engineering is a 5-year degree program that equips students with understanding of both engineering and chemical principles. It also helps learners how to build, manufacture, operate, and manage industrial processes. The course allows students to develop their expertise to analyze chemical processes, plan successful laboratory experiments to test hypotheses, and evaluate results. Students who want to pursue a degree in chemical engineering are encouraged to take the science, technology, engineering, and mathematics or the STEM strand under the academic track in senior high school. They will learn relevant topics that will be useful in their college life. For the subjects and curriculum, under here are the advanced engineering mathematics in chemical engineering, physical chemistry for engineers, chemical engineering calculations, chemical engineering thermodynamics, chemical process industries, introduction to particle technology, chemical reaction engineering, and laws and ethics for chemical engineers. To become a registered chemical engineer in the Philippines, a graduate of Bachelor of Science in Chemical Engineering needs to pass the Chemical Engineering Licensure Examination. The examination is conducted by the Board of Chemical Engineering under the supervision of the Professional Regulations Commission or the PRC. Graduates of chemical engineering may pursue a career path in various development and agriculture companies or government agencies that need specialized chemical engineering services. They may apply for roles such as a chemical engineer, manufacturing engineer, plant processes engineer, quality control engineer, process safety engineer, or even a chemical engineering professor. Many individuals are surprised by the quantity of chemistry required to a chemical engineering degree. Eventually, as with any engineering degree, physics and math are the most essential aspects of the course, with chemistry, particularly physical chemistry, accounting for around 20% of the course. Some aspects of chemical engineering are connected to biology. However, these are often more specialized domains. A chemical engineering degree is certainly not for you if you want to specialize in chemistry. Fortunately, chemical engineering requires the formulation and manufacture of items by chemical processes. These require establishing machinery, methods, and techniques for refining raw materials, as well as mixing, compounding, and processing chemicals. Chemical engineering is most often found in large-scale manufacturing plants, where the goal is to maximize productivity and product quality while minimizing costs. The aerospace, automotive, biomedical, electronic, environmental, medical, and military industries use chemical engineering to develop and improve their technical products, such as ultrasonic fibers, fabrics, and adhesives for vehicles, biocompatible materials for implants and prosthetics, and films for optoelectronic devices. Now, I have a question, and I bet some of you would like to ask this question as well. Is chemical engineering a difficult engineering course? Well, chemical engineering is undeniably challenging. It involves a lot of physics and maths, and is likely to involve a high number of exams at degree level. However, it is also varied and interesting, and if you are comfortable with the scientific requirements, committed to persevering, and genuinely interested in the subject, you are likely to succeed. What do chemical engineers do, and how to become one of them? Many of the mass-produced items ordinary people encounter and utilize regularly, ranging from cosmetics, electronics, and fuel to plastics, medicines, and processed foods, could not have been created in bulk at factories without the assistance of chemical engineers. Chemical engineers are many times tasked with bringing to life something that is just an idea, which is according to Brandon Webster. Without chemical engineers, product development would be phenomenally slow, and the products such as electronics, food systems, energy, anything plastic, paper or pulp, pharmaceuticals would be much less efficient and in some cases would not exist, he added. Chemical engineers in general conceptualize and develop processes produced by the chemical manufacturer. Chemical engineers' primary responsibility is to develop and troubleshoot processes for the manufacture of chemicals, fuels, foods, medicines, and biologicals, to mention a few. They are extensively used by large-scale manufacturing operations to increase productivity and product quality while lowering costs. Chemical engineers work in a wide range of industries, along with not only the petrochemical and the pharmaceutical industries, where they are typically applied, but also a variety of other industries that involve the creation and sale of tangible objects such as beverages, clothing, fertilizers, paper, toys, and shoes. They can also engage in water desalination and sanitation facilities, as well as recycling operations. Chemical engineers affect the production of almost every article manufactured on industrial scale. Some typical tasks include ensuring compliance with health, safety, and environmental regulations, conducting research to improve manufacturing processes, designing and planning equipment layout, incorporating safety procedures for working with dangerous chemicals, monitoring and optimizing the performance of production processes, and estimating production costs. Chemical engineers who work in business and management offices often visit research and production facilities. Interaction with other people and team collaboration are critical to the success of projects involving chemical engineering. Chemical engineers typically work in manufacturing plants, research laboratories, or pilot plant facilities. They work around large-scale production equipment that is housed both indoors and outdoors. Accordingly, they are often required to wear personal protective equipment or PPE. Examples are hard hats, goggles, and steel-toe shoes. Chemical developers can create and execute any manufacturing plant systems required to generate purified chemicals, integrate recipe ingredients, and manage hazardous waste. These engineers will periodically choose the components and compounds that will be involved in creating an item with certain properties, such as the capacity to conduct electricity or withstand heat. They research the atomic and molecular compositions of whatever solids, liquids, and gases a company employs in order to assess whether these materials should be processed and to propose techniques for reducing environmental pollution. One of the primary responsibilities is to certify that every chemical-infused product is harmless and efficient before it extends to a consumer. Another component of their role is to keep plant employees safe from chemicals and to avoid unintentional explosions. Further, according to chemical engineers, the potential to detect impending disasters and avert misfortune is necessary in this profession, which needs problem-solving abilities. According to chemical engineers, creativity is also vital for this career because they are constantly tasked with finding out how to do complex tasks. They go on to say that talent, curiosity, and extensive training in math and science were expected for the highly specialized profession. Andrew Zidney, a professor of chemical engineering with an endowed faculty post at Pennsylvania State University, notes that chemical engineers were involved in creating monoclonal antibodies used in cancer treatments and also helped with the development of the coronavirus vaccines. He notes that these engineers also assist with the production of lightweight, fuel-efficient vehicles. A quantitative mindset is valuable for a future chemical engineer, adds Zidney, who has both a bachelor's and a PhD in chemical engineering. They should be comfortable solving problems where the goal is to come up with a number as the answer as opposed to just a qualitative descriptions, he suggests. According to Borden, the foundation of a chemical engineering degree is a coursework in math and a variety of the science disciplines, including not only a significant amount of chemistry, but also biology, material science, and physics. Above the foundation, there is a lot of time spent on processing data, managing projects, using engineering software, and using the equations inherent to the art of chemical engineering to answer a question or solve a problem, he says. From an education standpoint, the best outcome for a student is not to appreciate yesterday's solution, but to have the tools to solve the problems that remain unsolved. In conclusion, chemical engineering is again extremely broad, and there's a lot that you can go into, and you have the knowledge of chemistry, but also physics, engineering, fluids, heat flow controls, and so on. Thus, chemical engineering is responsible for technology innovation through mass production, product quality control, materials recycling, high-quality device fabrication, and structuring knowledge. Now, chemical engineering has contributed to the development of an industrialized society in the 20th century. That would be all. Thank you for listening, and indeed, chemical engineers are sometimes called the universal engineers.